In the last video, we have discussed about the strength of materials and discussed about yield stress, and we have seen what you mean by plastic deformation. But now our question is, so if we have done the uniaxial tensile stress test, and you have the stress strain plot, and we have plotted like this. We have defined the yield stress and plastic deformation. But now the question is, what happens? What happens to the internal structure of due to plastic deformation, due to plastic deformation. See what is happening to the internal structure. We have seen the or seen the examples of the crystal structure, how these atoms are arranged in atoms in a crystalline way. So what happens to this crystal structure during plastic deformation? For that, suppose, see, you had a crystal structure like this. Okay, so that means the atoms are arranged in the regular positions. So let us assume like that. Okay. So that means, see, you are applying a shear stress. Okay, you are applying a shear stress. Okay. It plastically deforms. Right? It is getting plastically deformed. See, can we predict the internal structure of this one? So, see, okay. So three possibilities are the see you can assume that the crystal structure changes here. Okay. So the first possibility is crystal structure changes. The second possibility is that the crystal structure will not change. That means it deforms. Okay. It deforms, but the crystal structure will not change. That means crystal structure will look like this. Okay, crystal structure will not change. Structure will not change. And another possibility is that, see, the this will become amorphous. Okay, so I mean, its crystal structure completely gets damaged and it will become amorphous. So these are the three possibilities that can okay, that material becomes amorphous just like glass. All the crystalline properties are lost, right? But we have examined, okay, we have done an experiment and examined the internal structure after deformation, and let us see what is that. Experiment using X-ray diffraction. We can use the X-ray diffraction technique to find out the internal structure after deformation. So what we found was that when a material deforms, what we found was that crystal structure remains intact. That means crystal structure does not change, does not uh, change. That is what we observe. So, so what is this mechanism of plastic deformation? Okay, so that is the next question. See what is happening there. Without changing the crystal structure, how is this deformation occur? So this happens because of a process called slip. Okay, so that means you have a crystal structure like this. You have a crystal structure like this. So that means it deforms. See, this is what is happening to the crystal structures. Crystal structure as such remains intact. That means here you can see see, this is how this deformed material looks like. Okay, this is how the deformed, and the planes along which the slip takes place are called slip planes. It is called slip planes. Yeah, these are the slip planes, and this direction in which slip takes place are called slip direction. Directions are called slip direction. So let us examine this process, that is slip, in detail. So slip is seen that it is a plastic deformation that takes place along takes place on certain crystallographic directions, big directions, crystallographic planes along certain crystallographic directions. Along crystallographic directions. See, we have already studied in our first chapter about Miller indices and how you can assign the Miller indices to various planes and directions. That means slip takes place along certain planes and also in certain directions. So we can make use of these Miller indices to specify that planes. So slip planes means crystallographic plane, crystallographic plane for slip dire for slip, and the slip direction means the crystallographic directions for the slip, right? And these together form what is called slip system. So which we will study in detail. Slip system for various crystal structures in detail. Just give you some idea. That means for different crystal structures, you have different slip systems. For example, for a cubic closed pack structure that includes face-centered cubic structures and body-centered cubic structure, the slip planes, okay, the slip planes are given by the Miller indices. 111. This is the family of slip planes, and the slip directions are given by 110. 110. That means, see here the total number of slip planes is 4. So this is given by the family of slip planes, that is 111. So number of slip directions are 6. So the slip system is defined as a combination of these slip planes and slip direction. So similarly, for an hexagonally closed pack structure, you have the slip planes as so here in hexagonal closed pack structure, the Miller indices there are four numbers. So the slip planes are 0001 and slip directions are 112 bar 0. Okay. So the slip system is 001, okay, and 112 bar 0. So we will have a detailed look on these various slip planes and slip directions in another lecture. In next video, we will actually go to the mechanism of sleep. So what exactly happens during sleep?